All right, 4.5, analyzing lines of fit. Starting off, a residual is the difference of the y value of the data point and the corresponding y value found in the line of fit. A residual can be positive, negative, or zero. So looking at this picture here, we have our line of fit there, and we have this data point up here. Well, that's above our line of fit. So to find the residual, we would take the data point for the line of fit, maybe it's like 6, and the piece of the line, maybe that could be like 2, so the residual would be, what would that be, 4. So if this one over here, and those aren't necessarily great numbers, but it's just meant to show you what we're doing. And the same thing for the negative one, right? You take the top one minus the bottom one. Ideally, hopefully it makes sense that you really want the residual to be 0, right? You want your data points to be on this line of fit, because then it's like a perfect representation of that data point. If you want a more worked out example of that, you can look at example 1 on page 212. All right, using a graph or its equation to approximate a value between two unknown values is called interpolation. Right, so if we're looking at this graph up here, say we have this data point right here and this data point right here. If we were to interpolate, we would look at anything that's between them, right? Interpolate inside, right? Interpolate inside. Extrapolation is whenever we use them to predict. So we've got those two green points there. If we were to predict what it does out here, that would be using extrapolation, because that's after our data points. That's after the data points that we've seen. When a change in one variable causes a change in another variable, it's called causation. Causation produces a strong correlation between two variables, right? And this is telling us that the converse is not true. Correlation does not imply causation. So just because you see two things change together doesn't mean that they're causing each other to change, right? You could think about, I don't know, growth outside on flowers, right? Two flowers next to each other might grow at about the same rate. That doesn't mean that flower number 1 is causing flower number 2 to grow. It means the sun is probably hitting both of them, right? So just because two data points are changing together does not mean that they're causing each other to change, right? Scrolling down, we're talking about linear regression. Linear regression is something that we normally do on a calculator, on a graphing calculator. So I'm not actually going to do it with you guys here, but I will talk about it just a little bit. Linear regression produces a line of best fit, or a line of fit. Whenever we do this in our calculator, sometimes it'll give us an R value, right? R value, we look up here. Here we have residual. R is similar to that, called the correlation coefficient. When R is close to positive or negative 1, there's a strong correlation between the variables. As R gets closer to 0, the correlation is weaker, right? Example number 10 is needed to be done on a graphing calculator, so I'm not going to do that with you here. So you'll have to talk to me or go on YouTube and look for someone else that does that. But let me talk just a second about this piece that it said right here. If you have a homework problem and it tells you that the R value is maybe like R equals 0.001 or something like that, you would say, well, that's not a very good correlation, right? Now, if it was R equals 0.94, right, that would be probably a pretty good one, because that's very close to 1. If it was R equals negative 0.98, that would be an even better one, because it's very close to negative 1, right? So if it's close to positive or negative 1, that's really good. It's whenever it gets close to 0 that's bad. All right, so let's make sure that we have the residual thing copied down. We've got interpolation and extrapolation, good grief, extrapolation, and there it is. Good luck on the homework.